Assalamu alaikum. Bismillahirrahmanirrahim. I am Muhammad Qasim from Department of Computer Science. We will study the second part of our unit 9, that is cryptography. Let us start our today lecture. Hashing algorithm. Today our topic in cryptography is hashing algorithm. Message digest or summarize of message content. Unlike a files checksum produced by hashing algorithm. It's extremely difficult, if not impossible, to derive a message from an ideal hash function, and it's very unlikely to two messages will produce the same hash value. This is a hashing algorithm used for security of message at the receiving end to check it whether the message is reached in original format or not. The following are the some of the more common hashing algorithm used in today transformer data communication. Message digest to MD2, message digest for MD4, message digest file MD5, secure hash algorithm SHA, hash base message authentication code HMAC. Symmetric cryptography we have studied already have different algorithm. And symmetric cryptography we have a single secret key that is used by the sender and by the receiver have the same secret key. Sender use plaintext algorithm to use the key and produce crypto or cipher text encryption, and the other end decryption algorithm used by the user receiver and having the same key to produce plain text again. This type of technologies are used in data encryption standard algorithm, triple DES, 3DES, international data encryption algorithm IDEA, bluefish algorithm, skepjack algorithm, advanced encryption standard algorithm. Let us study these algorithms. Data encryption algorithm. United States government published the data encryption standard DES in 1977 as a proposed standard encryption crypto system for all government communication, superseded by advanced encryption standard AES in December 2001. This is a 64-bit block cipher that has 4 modes of operation. It used 64 blocks of message, divided the message into 64-bit blocks, and then used these techniques operations. Electronic code book EBC mode, cipher block chaining mode CBC, cipher feedback CFB mode, output feedback OFB. Modern cryptography include all these algorithms. All of the DES modes operation or operate on 64-bit of plain text at a time to generate 64-bit block of cipher output. The key used by DES is 56-bit long key for the algorithm to encrypt the message. DES utilize the long series of exclusive OR, we called it XOR operation, to generate the cipher text. This process is repeated 16 times for each encryption or decryption operation. Each repetition is commonly referred to as a round of encryption, explaining the statement that DES performs 16 rounds of encryption in series. Electronic code book mode as the simplest mode to understand and as least secure. Each time the algorithm processes a 64-bit block, it simply encrypts the block using the chosen secret key. This means that if the algorithm encounters the same block multiple times, it will produce the exact same encrypted block as a cipher. Cipher blockchaining mode. Each block of unencrypted text is XORed with the block of cipher text immediately preceding it before it is encrypted using the DES algorithm. The decryption process simply decrypts the cipher and reverse the XNOR and operation. CBC implement IV and XR with the first block of the message producing a unique output every time the operation is performed. Cipher feedback CFB mode is the streaming cipher version of CFB. CFB operate against data produced in a real time. Instead of breaking the message into block, it uses memory buffer of the same block size. As the buffer becomes full, it is encrypted and then sent to the recipient. System wait for the next buffer to be filled as the new data is generated before it is in turn encrypted and then submitted or transmitted. Output feedback OFB mode. This operates in almost the same fashion as it does in CFB mode. However, instead of XRing an encryption version of the previous preceding block of ciphertext, this XR the plain text with the seed value. For the first encrypted block, an initialization vector is used to create the seed value. Future seed values are derived by running the DES algorithm on the previous preceding seed value. Triple DES algorithm use 3 rounds of algorithm with different keys. Uses same algorithm to produce more secure encryption. There are 4 versions of 3DES. The first simply encrypt plain text 3 times using 3 different keys K1, K2, K3. It is known as DES EEE3 mode. E's indicate the 3 encryption operation. Numeral 3 indicate that 3 different keys are used. This algorithm can be expressed using the following notation where encryption key plain text represent the encryption of the plain text P with key K. This EE3 has an effective key length of 168 bit. Encryption key 1 and then encryption again K2 and then encryption again K3 using plain text. The second variant of DES algorithm EDE3 also uses 3 key but replaces the second encryption operation with the decryption operation. Like first it encrypt key 1 using key 1 and then decrypt using key 2 and then encrypt key 3 the plain text. The third version of 3DES as DES EEE2 using only 2 key K1 and K2 as follows. First it encrypt the message with using K1 and then K2 and then again encrypt with K1 the plain text. This produce ciphertext. The fourth variant of 3DES as DES EDE2 also uses 2 keys but uses a decryption operation in the middle, like encrypt using key K1 then decrypt using key 2 and then encrypt K1 using key for plain text. Both the third and fourth variant have effective key length of 112 bits. International data encryption algorithm block cipher was developed in response to complaint about the insufficient key length of DES algorithm. Like DES, idea operate on 64-bit block of plain text or ciphertext. begin its operation with the 1 to 8 bit of key. The key is longer than the DES algorithm, where DES algorithm use 64 bit, it use 1 to 8 bit. The key is then broken up into a series of operation into 52 of 16-bit subkeys. The subkeys then act on the input text using a combination of XOR and modulus operation to produce the encryption-decryption version of the input message. IDEA is capable of operating in the same four modes utilized by DES: ECB, CBC, CFB, and OFB. The IDEA algorithm itself is a patent by its Swiss developers. They have granted an unlimited license to anyone who wants to use IDEA for non-commercial purposes. Bluefish algorithm. Bruce Scheiner, Bluefish block cipher is another alternative to DES and IDEA algorithm. Bluefish operate on 64-bit of block of text. It extend IDEA's key strength even further by allowing the use of variable length keys ranging from alternative increase 32-bit to an extremely strong 448 bits of key. Longer key will result in corresponding increase in encryption-decryption time. Time trial have established Bluefish as a much faster algorithm than both IDEA and DES. Sanger release Bluefish for public use with no license required. Bluefish encryption is built into a number of commercial software product and operating system as well. There are also a number of Bluefish libraries available for software developers. Skepjack algorithm approved by US government and Federal Information Processing Standard FIPS 185 document, the escrowed encryption standard EES. Skepjack operates on 64-bit block of text. 80 bits of key is used and support the same four mode of operation supported by DES algorithm. Quickly embraced by the US government and provides the cryptographic routine supporting the Clipper and Capstone high-speed encryption chips designed for mainstream commercial use. Advanced Encryption Standard AES. In October 2000, the National Institute of Standards and Technology (NIST) announced that the Reinel block cipher, pronounced as Reinel doll, has been chosen as the replacement for DES. In December of that same year, the Secretary of Commerce approved FIPS 197 document, which mandated the use of AIS Reinel for encryption of all sensitive but unclassified data by the US government. The Reinel cipher allowed the use of three key length: 128-bit key, 192-bit key, 256-bit key. The original specification of AES called for the processing of 128-bit block, but Reinel exceed this specification, allowing cryptographers to use block size equal to the key length. The number of encryption round depend upon the key length chosen. 128-bit key required 9 round of encryption, while the 192-bit of key required 11 round of encryption. 256-bit key require 13 round of encryption. Reinel algorithm uses 3 layer of transformation to encrypt block of message: linear matrix max transform, nonlinear transform, key addition transform. The total number of round key bit needed is equal to the following: block length multiplied by number of rounds plus 1. For example, with a block length of 128 bit and 13 round of encryption, 1792 round key bit are needed. Modern cryptographic algorithm includes, and our lecture have the list with its block size and its key size as well. Now next topic is key distribution. How can we distribute the key to the all user and the organization for securing their information? Major problem underlying symmetric encryption algorithm as the secure distribution of the secret key required to operate the algorithm, where the key is single and can be distributed to the all user within the organization. Some method use the exchange of secret key securely or offline distribution. The most technology simple method involve in the physical exchange of key. One party provide the other party with the sheet of paper or piece of storage media containing the secret key. And many hardware encryption devices like this key material comes in form of electronic device that resemble an actual key that is inserted into the encryption device. If participants recognize each other voice, they might use the tedious process of reading keying material over the telephone. However, each of these method has its own inherent flaws. If keying material is sent through email, it might be interrupted or intercepted by user. Telephone can be wiretapped. Paper containing keys might be advertently thrown in the trash or lost. For this, we use some algorithm to securely transfer the key. Public key encryption. Many communicator want to obtain a speed benefit of secret key encryption without the hashless of key distribution. Use of public key encryption to set up an initial communication link. Link is established and the parties are satisfied as to each other identity. They exchange the secret key over the secure public key link. Then switch communication from public key algorithm to secret algorithm and enjoy the increased processing speed. In general, secret key encryption is 1000 times faster than public key encryption. Diffie-Hellman. Diffie-Hellman have introduced, two scientists have introduced a key exchange method. When neither public key encryption nor offline key distribution is sufficient, two parties might need to communicate with each other, but they have no physical mean to exchange key material, no public key infrastructure in place to facilitate the exchange of secret key. Use key exchange algorithm like Diffie-Hellman algorithm prove to be extremely useful mechanism. And Diffie-Hellman algorithm work as follows. The communication party agreed on two large number p, which is a prime number, and g, which is an integer, such that g greater than 1 and p greater than g. Richard choose a random large number integer, one user, and perform the following calculation: r is equal to gr mod p. Second user chooses a random large number s and perform the following calculation: s is equal to g mod p. The first user send r to the second user Su, and Su send s to the first user. Richard then performed the following calculation: k is equal to sr mod p. So second user then performed the following calculation: k is equal to rs mod p. At this point, Richard and Su, both the user first and second both user, have the same value k, and can be used this for secret key communication between two parties. The whole process is shown in the figure. He choose private p as 5. The second user choose 4. So prime number chooses as 13 and generator of P as 6. Now the use of 6 raised to the power 5 mod 13, which produce 2, and he also calculated 6 raised to the power 4 mod 13, which is equal to public is equal to 9. Now they both exchange this public key to each other. He exchanged 9 to first user, and first user 9 raised to the power 5, which is private number, or mod 13, calculate that secret key has become 3, and the first user send the key, the number public number 2 to the second user. Then he used the exponential method, 2 raised to the power 4 mod 13, which is equal to 16 mod 13, which is equal to 3. The secret key become available to each other without the any third party usage. Key escrow. To handle the explosive growth of cryptographic technology, government around the world have floated idea to implement key escrow system, allowing the government under limited circumstances such as court order to obtain cryptographic key used for particular communication from a central storage facility. Two major approaches to key escrow that have been proposed. Fair crypto system escrow approach. The secret key used are divided into two or more pieces, each with its which is given an independent third party. Each of these pieces is useless to its own, but may be recombined to obtain the secret key. When the government obtain legal authority to access a particular key, it provide evidence of the court order to each of the third party and then assemble the secret key. Second is escrowed encryption standard takes a different approach by providing the government with the technological mean to decrypt ciphertext. This standard is the basis behind the skip algorithm. Thank you for our second part of our unit 9 cryptography. This conclude our unit today unit, and this also conclude our course. You can study the allied material for the second part of this unit. We have provided on the screen as well. This is the end of our course. We have completed our course of information technology 9 units. Thank you. Allah Hafiz.